According to NEC Article 725, circuits associated with emergency systems are classified as follows. Firstly, emergency circuit, which supplies vital loads necessary for life, safety, or protection of property. Secondly, legally required standby circuit, which supplies legally required loads such as fire pumps, emergency lighting, and elevator emergency power. And thirdly, standby circuit, which supplies optional equipment or systems. In this case, the current transformer secondary circuit is not directly connected to the emergency system loads. Instead, it provides a scaled representation of the generator set output for monitoring purposes. As such, it would likely be considered a signaling circuit. NEC Article 725.43 requires that signaling circuits be installed in accordance with the requirements for Class 1 circuits. Class 1 circuits are defined as circuits that provide power for signaling devices such as annunciators, alarms, and control systems. The NEC requires that Class 1 circuits be installed in a manner that ensures their integrity and reliability. This includes using appropriate wiring methods, protecting the circuits from physical damage, and ensuring proper insulation and grounding. Based on the classification as a signaling circuit, the current transformer secondary circuit between the transfer switch enclosure and the remote meter enclosure should be installed in accordance with the requirements for Class 1 circuits. This includes using appropriate wiring methods, protecting the circuit from damage, and ensuring proper insulation and grounding. To further clarify the requirements for Class 1 circuits, it's essential to delve into the specific sections of NEC Article 725 that address their installation. Firstly, conductors for Class 1 circuits must be insulated and suitable for the voltage and environmental conditions. Secondly, the wiring methods must comply with Chapter 3 of the NEC, which outlines approved methods such as using conduit, cable trays, or direct burial cables. Thirdly, overcurrent protection is crucial. Class 1 circuits must have overcurrent protection devices, such as fuses or circuit breakers, sized appropriately for the ampacity of the conductors. This protects against short circuits and overloads. Fourthly, grounding is vital for safety. Class 1 circuits must be properly grounded in accordance with Article 250 of the NEC to minimize the risk of electric shock. Fifthly, separation from other circuits is often required. Class 1 circuits should be physically separated from power circuits to prevent accidental contact or induction, which could create hazards. Sixthly, marking and identification are important. Conductors and equipment related to Class 1 circuits should be clearly marked and identified to facilitate maintenance and troubleshooting. Seventhly, for specific applications, such as those in hazardous locations, additional requirements may apply. Article 500 of the NEC provides guidance on wiring and equipment in hazardous locations. Eighthly, when running Class 1 circuit conductors in the same raceway or cable with power conductors, specific rules apply to ensure insulation integrity and prevent voltage induction. Ninthly, the ampacity of Class 1 circuit conductors must be determined based on the temperature rating of the conductors and the ambient temperature conditions, as outlined in NEC Table 310.15. Tenthly, proper support and skewering of the wiring is necessary to prevent strain on terminations and ensure long-term reliability. 11thly, when Class 1 circuits extend beyond one building or structure, additional requirements for overcurrent protection and disconnecting means may apply. 12thly, regular inspection and maintenance of Class 1 circuits are crucial to ensure continued compliance with the NEC and to identify any potential issues before they become hazardous. In the context of the current transformer secondary circuit, the low voltage and low current characteristics might lead one to consider Class 2 or Class 3 circuits, which have less stringent requirements. However, because the application involves an emergency system, it is safer and more prudent to adhere to the Class 1 circuit requirements for increased reliability and safety. Furthermore, the 1000 to 1 current transformer ratio implies that a significant fault current on the primary side could produce a higher current on the secondary side, necessitating robust wiring and protection. Considering the installation environment, ensure that the wiring between the transfer switch and the garage is protected from physical damage. This may involve using conduit or other suitable protective measures, especially if the wiring is exposed or run underground. In areas prone to moisture or corrosion, use appropriate conduit and fittings that are resistant to these conditions. Select conductors with insulation suitable for wet locations if necessary. Also, when routing the wiring, avoid areas where it could be subjected to mechanical stress or abrasion. Secure the conduit or cable properly to prevent movement or strain on connections. When connecting the current transformer secondary wires to the meter in the garage, use terminals or connectors that are rated for the specific wire size and type. Ensure that all connections are tight and properly insulated to prevent shorts or ground faults. Clearly label the wiring at both ends to identify the current transformer circuit. This will facilitate future maintenance and troubleshooting. When selecting the overcurrent protection device for the Class 1 circuit, consider the ampacity of the conductors and the characteristics of the current transformer. The overcurrent device should protect the conductors from overload without nuisance tripping. Before energizing the circuit, thoroughly test the wiring and connections to ensure that there are no shorts, ground faults, or other wiring errors. Use a multimeter or other appropriate test equipment to verify the integrity of the circuit. After installation, periodically inspect the wiring and connections to ensure that they are in good condition and that there are no signs of damage or deterioration. Address any issues promptly to maintain the safety and reliability of the circuit. Keep a record of the installation, including wiring diagrams, equipment specifications, and test results. This will be helpful for future maintenance and troubleshooting. Ensure that the installation complies with all applicable local codes and regulations, in addition to the NEC requirements. Local authorities may have additional requirements that must be followed. The NEC is updated regularly, so it is important to stay current with the latest edition to ensure that your installations comply with the most recent requirements. By carefully following these guidelines and adhering to the requirements of NEC Article 725, you can ensure that the current transformer secondary circuit is installed safely and reliably, providing accurate monitoring of the generator set output. Remember to consult with a qualified electrical inspector or engineer if you have any questions or concerns about the installation. Their expertise can help ensure that the installation meets all applicable codes and standards. Always prioritize safety when working with electrical circuits. To energize the circuits before working on them, and use appropriate personal protective equipment, such as insulated gloves and safety glasses. Following these precautions will help prevent electrical shock and other injuries. When choosing conductors, consider the voltage drop in the circuit. Excessive voltage drop can affect the accuracy of the meter readings and the performance of the circuit. Select conductors with an appropriate size to minimize voltage drop. Use a voltage drop calculator or consult with an electrical engineer to determine the appropriate conductor size. In addition to overcurrent protection, consider using surge protection devices to protect the circuit from voltage surges caused by lightning or other electrical disturbances. Surge protection devices can help prevent damage to the meter and other equipment. When installing the wiring, avoid running it near sources of heat or electromagnetic interference, as these can affect the accuracy of the meter readings. Maintain a safe distance from these sources to minimize their impact. Consider the ambient temperature when selecting equipment and conductors. Extreme temperatures can affect the performance and lifespan of electrical components. Choose equipment and conductors that are rated for the expected temperature range. When making connections, use appropriate crimping tools and techniques to ensure that the connections are secure and reliable. Poor connections can cause overheating, voltage drop, and other problems. If the current transformer secondary circuit is exposed to moisture or corrosive substances, use corrosion-resistant materials and coatings to protect the wiring and equipment. Inspect the installation regularly for signs of corrosion and take corrective action as needed. When working with current transformers, be aware of the potential hazards associated with open-circuited secondaries. Never open-circuit the secondary of a current transformer while the primary is energized, as this can produce dangerously high voltages. Always short-circuit the secondary before disconnecting it from the meter. If you are not familiar with the proper procedures for working with current transformers, consult with a qualified electrician or engineer. They can provide guidance on safe work practices and help you avoid potential hazards. By following these additional guidelines and best practices, you can ensure that the current transformer secondary circuit is installed safely, reliably, and in accordance with all applicable codes and standards. Always prioritize safety and consult with qualified professionals when needed. The NEC is a comprehensive document, and it is essential to consult the specific sections that apply to your installation. In addition to Article 725, other articles may also be relevant, depending on the specific circumstances. For example, Article 300 covers general wiring methods, and Article 250 covers grounding and bonding. It is also important to be aware of any local amendments to the NEC that may be in effect in your area. Local authorities may have additional requirements that must be followed. When in doubt, consult with a qualified electrical inspector or engineer to ensure that your installation complies with all applicable codes and regulations. They can provide expert guidance and help you avoid costly mistakes. Remember that the information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals before undertaking any electrical work. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from harm. By following these guidelines and seeking professional advice when needed, you can ensure that your electrical installations are safe, reliable, and compliant with all applicable codes and standards. And most importantly, double and triple check your work.